Okay, so when we left off, I was just about to give you a little explanation of why that. Doesn't it feel wrong that this should equal 1 and this should equal 1? It bothers me a little bit, and until I got a good explanation, and I've got a good explanation that I can give you. 3 to the third is 3 times 3 times 3, right? And then 3 to the second is 3 times 3. And 3 to the first is 3. And it just seems like, well, you just have one less 3 each time, right? And so why should 3 to the 0 be 1? Well, it's because you're looking at the pattern wrong. How do you get from here to here? Divide by what? How do I get from here to here? Divide by 3. What happens when I take 3 and I divide by 3? 1. And that'll be true for any number. Like if I can do that with 7s if I want to. 7 to the third is 7 times 7 times 7. 7 to the second, 7 times 7. 7 to the first, 7. 7 to the 0. Well, this one's divide by 7. Take 49, divide by 7. Take 7 divided by 7, and I get 1. You just were looking at the pattern wrong, if that didn't make sense before. Okay, next one, power of a product property. I can do this. Some of you might be saying, I can just take 5 times 4 is 20, and 20 squared is 400, and the answer is 400. And you're right. So what's the point of having any property? Well, because sometimes this isn't a 5 and a 4. Sometimes it's an M and a Q. And you need to know what to do if this was like variables in here. Well, is it okay to square 5 and square the 4 and then multiply them? I'm going to check and find out. 5 squared times 4 squared. It better equal 400 because I know the answer is 400. 5 squared is 25. 4 squared is 16. You know what 25 times 16 happens to be? 400. So it is okay. But what's not okay is doing this, for instance. Very common for people to think, oh, well, that's just x squared plus 4 squared. That won't work. If it's plus, it won't work. I'll prove it with numbers. What's 1 plus 4? 5 squared is 25. So the answer should be 25. So can I take 1 squared plus 4 squared? 1 plus 16 is 17. It doesn't equal 25 like it's supposed to. Right? So you can't just assume. You have to know. And when we could say that in this situation, that for the principles of exponents, we cannot write this as 1 squared plus 4 squared. But when you're doing the multiply kind, you can take this squared and that squared. A simpler example that you might recognize would be if I said 5a squared. That's really the same example. There's just no big time sign in here. So what's 5 squared? What's a squared? 25a squared. And you're allowed to do that. And you're supposed to do that. All right. So moving on. Power of a quotient. This is a fraction, and the fraction is being raised to an exponent. Well, this is fairly simple. If I want to make myself a little mini bite-sized problem that's like this, I could say it's 2/3 to the second. Right? That's a nice simple problem with numbers. What can I do to get this to multiply out? Can I take each of these and just put it to the n on both of those or not? Well, I'll just test it quick for you. 2/3 squared should be 2/3 times 2/3, and that is 4/9, right? Can you just look at these and tell me, can I just square the top and square the bottom? Yeah, I can. 2 squared is 4, 3 squared is 9, 4/9. Worked. Okay, so if I had to answer this with variables, what's on the board right now? Can you answer that? A to the n over b to the n. That's it. All right. Now, some of these you've been sleeping through, and because they've been like, yeah, I did this last year and the year before that. But a couple of these next ones are important and kind of challenging, so stay with me. If a equals b, then a to the n equals b to the n. This one's pretty simple still. If a equals b, like 5 equals 5, set two things equal, then if I square both sides, or put it to any power on both sides, it'll still be equal. That's all that says. The only thing that gets weird about that is sometimes it doesn't look like two things are equal, but you can still square them. Like, for instance, sine of theta is equal to 25. I can put it both of these to a power. I can put this to the second and that to the second. And then that's allowed. So that's all its property is saying. And the way you'd write that, you'll do more trig next year. Sine squared of theta. All right. Now, this property is the biggie, though. Common base property. Put a star by this one and write it in your notes. Because of all the properties, the biggest things were that negative exponents that are negative. Remember, it just flips them. And then this. This one is important. For an example, here's a really easy example. If I use 2 as my base, and they're both the same, then the exponents will have to be the same. So if this is like a 3 here, well, then that has to be a 3 there, right? That just makes sense. But sometimes, of course, they make it more complicated. What if they say this is x? And it's still not that complicated. This property tells me what? X must be 3. See? This has to equal that. So 3 has to equal x, so x must equal 3. All right. So then, what if it looked like this instead? 2x and 8. 2x has to equal 8, so x has to equal 4. Get what I'm saying here? So if you can get these bases the same, then these problems are easy. The hard part is getting the bases the same. And why am I teaching you this? Because this is an exponential. See? It's got an x in the exponent. And that's the only way to solve exponentials that you know of. It's another way called logs we're going to learn at the very end of the year. But for right now, this is the only way you can solve these things is by making those bases the same. Common base property. Okay, that's a big one. All right, so the ones I showed you were pretty easy. Now I got to give you, it's like the next step up. So here's one. Let's say I had 3/4 to the x equals 4/3 to the second. Write that one down. If they had the same base, this would be easy, but they don't. But I can make it so they do have the same base. All I have to do is get this fraction over here to get flipped over, and then they would have the same base. So I'm going to leave this one alone, and this one I'm going to flip, make it what I want. But how do I do that? I have to change my exponent to, I could put a -1 and a 2, or I could put it together all at once and just say that it's 3/4 to the -2. See what I did there? As soon as I got the bases the same, then this has to equal that. And the answer is x is -2. All right, I'm going to give you another one like that, see if you can handle it all by yourself. 4/5 equals, to the third, equals 5/4 x. Figure it out. So remember what I was saying was to make this base just what I want. I want it to be 4/5, so I'm going to make it 4/5. But then I have to do something to my exponent to make that actually true. What would I say? -x. If I put in that negative in the exponent, that's what causes it to flip. Now that has to equal that. 3 equals -x. So multiply both sides by -1, and I get x equals -3. Get that? All right, here's one more challenge one for you. You know what? We're not going to do a challenge one. We'll do that on your homework. I'm running out of time here. One last thing, fraction and a fraction. You're going to hit those. If you have a fraction and a fraction, remember that 1 over something is kind of like that reciprocal thing with the -1 as an exponent. All it means is take the reciprocal of whatever's down there. So let's answer this one. 3. So what if it had been like 1 over 2/3? It just means, what does that mean? Take the reciprocal of what's down there. So what's the answer? Get that? Just flip it over. All right. What's that one? 5/2. How about that one? All right. First of all, we take that means flip it. So it's what? 5 over 2. Flip it again. 2 over 5. Flip it again. 5 over 2. That's all there is to it.